Hello everyone and welcome back to this new video of the Agentic AI series. Today we are moving to the last component of the core components of Agentic AI, tool use and APIs. This component is what really transforms language models from being text generators to be operational agents, operational systems, and so on. In today's video, we will deep dive a little bit on some elements of these tool use and what are the considerations that we will look at here, how we examine the execution loop, discuss reliability and security, and we will build a fully runnable agent using real APIs, weather API, web search, flights, hotels, etc. And we will see these calls in real time, and I will share at the end of the video the notebook to for you to be able to run the code and regenerate it again. Without further ado, let's dive in. So, without tools, an LLM can interpret, reason, simulate, plan, whatever, but that's all in text. With tools, an agent can query live data through web search, trigger workflows, execute operations, affect external systems by altering their status or situation, and so on. So tools are what usually transform language models into operational assistants, as we said in the introduction. So we're speaking about tool use, and the question is, what is a tool actually in agent architecture? A tool is a named capability. It has a name, and it has a typed schema for its input, and it has structured output that really need to be controlled, and we will see why, especially in the implementation. And it has an external execution layer where it interacts with the external world. And the most important principle here is that the model doesn't execute the tool itself. The model generates a structured request to call the tool, and the orchestrator executes it, not the model. And this separation is critical actually here, because reasoning must remain probabilistic while execution should be deterministic. And this is where the separation is really important between what the model does in terms of probability and thinking, reasoning, etc., and the orchestrator what does is executing very specific tools with very specific names, with very specific type inputs, and expects a very specific outputs, and so on. Here we differentiate between three layers in this architecture. The first layer is the LLM, the large language model, that decides whether a tool call is needed, and then it generates a structured tool call after it selects which tool to call. And then the second layer is the orchestrator, that it validates the arguments, validates the parameters, executes the tool, and makes the actual execution there, the function or the API or whatever. And then it handles failures, it logs activities, and so on and so forth. So mainly the orchestrator is the hands of the LLM, while the LLM is the brain thinking. We can think about the orchestrator as the hands. And then we have the third layer, is which is the external APIs, whether APIs, web search, hotel search, enterprise systems, and so on and so forth, which are the connection between the orchestrator or the agent and the outside world in general. This layered structure prevents chaos, because if we mix them, we will lose the observability, we will lose the security, and we lose determinism. I mean, I'm saying we will lose because it will be so difficult to debug afterwards if failure happens. It will be so difficult to control the reasoning of the LLM and how which tools are calling without the orchestrator and so on. So this is really important here to maintain the control over the agent behavior as we move over time. So what happens in when we call a tool? I mean, when the agent decides that the tool call is needed. Let's look at this diagram. We start with a user request that goes to the model, which decides if a tool call is required, and then if yes, it will generate or it emits a structured tool call that will go to the orchestrator to validate the parameters, to validate the tool name, etc., and then execute the tool or execute the function. That will be through probably external API that will generate a structured result that will be delivered back to the model to reason on top of it and generate a final result to the user. This is can happen only in one iteration or multiple iterations, and that depends on the results and depends on the retries, the failures, and so on and so forth. For example, imagine a user says, find flights to Berlin next Friday. So the model doesn't say, I will now search flights. Instead, it will emit a structured JSON like tool is search flights, arguments, origin, destination, and departure date. And this is, so far, it's just the intention that will be not execution, that will be delivered to orchestrator that will inspect this object and then execute the corresponding function to the flight search or search flights. And then when we have the result, it will be sent back to the model to think about what we have got as a flights and recommend probably the best option to the end user. In tool use or in tool calls, we have two different approaches here. First one is deterministic, and it's something like if intent equal whether then call whether API. And this is very much predictable and limited flexibility. While we have another model or another approach that is model-driven tool selection. So the model chooses the tool dynamically. It is flexible, it is scalable, and enables multi-step workflow. So based on the reasoning, the model will suggest which tool will search for whatever tools they need to use or to call out of marketplace or whatever. And that will create more flexibility and scalability of what we can have at hand. While the first model or approach is more like very deterministic, and at the same time it's more secure because whenever we have greater autonomy, we need stronger control systems to enable or to make sure the agent doesn't hallucinate, doesn't overuse tools, and so on. So this is really important to keep in mind when choosing which approach you would use for your agent. When designing tools, we need to make sure that they follow some design principles or design patterns here. Tools, they should have a strong schema. Parameters should be typed, required fields should be identified or defined, and so on. It's better to have a single responsibility per tool, one clear function per tool, to avoid hallucination and to avoid uncontrolled results when the tool is so complex or complicated. Output should be structured, not as a free text, just JSON, very well maintained structure to make sure that we get the exact information that we want to get from the tool. And most important, I would say here, observability to log every tool call. That will allow us to debug when something happens. And believe me, things will happen, failure will happen, hallucination will happen. And without logging every single call, you will get lost and your agent will get lost. So it's important to have this as a core, a very much core principle for your tool design. The idea that good tools reduce hallucinations, and we need to keep this as a guiding principle for us. We don't want our agents to hallucinate. We need them to be, yes, flexible, yes, autonomous, but yet still to be very much accurate, disciplined, controlled, and to know what they are doing at every single step. Moreover, reliability must be engineered. Tool design must handle timeouts, must handle rate limits, must handle invalid parameters, must handle partial results, and so on. It must handle all of these things by design, not by guessing. And in production systems, agent will require, and we will have to implement retry policies, fallback strategies, graceful degradation, and so on. Otherwise, the tool use will introduce a fragility, and we will see how we implement these things in our notebook afterwards. But we will keep it simple there. But in a real system, reliability engineering becomes really essential. We will cover this a little bit, but you have to keep it in mind when you go to production systems. The moment your agent can act, it becomes a security boundary. There will be security issues, risks, range varies from prompt injections, unauthorized tool calls, data exfiltration, financial abuse, and so on. The list is very long, but these are just very a few examples. How we mitigate that? We need to define our tool whitelist. We need to ensure our argument and parameters validation. We need to have scoped API keys. We need to have rate limits defined for each tool call. We need to have approval layer, and we will see it later. We should see human in the loop as well as one of the design principles. And with these mitigations, we make sure that that risks, if they happen, they will continue to be under control, but not as a huge security breach or a security issue. Because autonomy without governance is dangerous, and we are using agents because they are autonomous, because they are capable, but we should ensure that we govern them. Here, this is a key principle. Lastly, observability and traceability. Production system must log for each tool call, the tool name, the parameter used, the timestamp, the response, the latency. Because without these parameters, debugging multi-step agents will become impossible, and that's very dangerous actually, and it's very risky. And we have seen in the previous slide about these risks. We need to have some kind of traceability, observability there to ensure that we know every single step that's happening when the agent is acting autonomously. So we keep an eye on them. This is a core infrastructure in the agent design, in the tool use, to make sure that we have the log there. That was the last slide of this on the overview of the tool use, and we coming to our famous slides. We see that we have covered all the core components so far now with the tool use and API. Next, we will move to our famous notebook demo. That will be a simple one, and I will guide you through this demo.